Hello, I'm Eddie Wiss, and today I'm going to be summarizing for you topological phase transitions and topological phases of matter. Now, before we get into the actual discovery made, some background information is necessary. So, as we know, matter can be described as a series of phases: solid, liquid, gas, and sometimes plasma. These are what is known as the four fundamental states of matter, all of which can be easily described physically since we can see them. The gas not so much, but that can be seen through the vapor of gas. However, it is at very extreme temperatures, near absolute zero, that matter behaves quite strangely. How they explained this was using topology, which in essence is a way to study what properties are conserved when matter or objects are contorted in any which way. And what this means is that if you have an object and you were to tear it in half, it would still retain the properties such as its magnetism or electrical potential. Now, as we get into the actual discovery, the three laureates were able to figure out how films of materials, typically near absolute zero again, change their phases of matter and how the transitions would then affect their properties. For example, their magnetism or electrical potential, as I was explaining. Past this theorization, this has led to the development of materials with properties such as only conducting electricity on their surface. And this is important because what is commonly known is that the electricity or a current will run through a material. And these have been dubbed or named as topological insulators. And if you look at the figures below, figure A and B, you see the electricity on a 2D topological insulator moving only along the dimensions of the insulator, not on the inside. And when looking at figure B, something a little easier to understand because it's three-dimensional and we live in a three-dimensional world, you see the electricity moving only along the outsides of the insulators. And the importance of this discovery has not been fully realized yet because it is still a new topic, and it is only very briefly being talked about because it's been experimentally proven. However, many do speculate that the discovery of these topological insulators will accelerate the potential of computing, and more specifically, quantum computing. With the combination of topological insulators, superconductors, and metals, great advances in electronics and computing are speculated. And that, in and of itself, is incredibly important due to the fact that we live in a very technology-heavy world. It's been 20, 30 years since only then computers were being revolutionized, and now everyday people just have a super powerful computer in their pocket. It's incredible. And as technology does not stop going. It keeps advancing and advancing. And that is also important because that means that we need more and more scientists, more and more chemists, physicists, engineers to keep technology going, to keep laying down the track for technology to push along. And that is incredibly important because technology also makes daily life much easier. If it weren't for technology, we'd still be relying on roosters to wake us up at the crack of dawn instead of our alarm clocks. Now, the effect on the scientific community has since the discovery has been proven experimentally with several types of materials, one of which was originally helium, which is what the laureates used, which is one of the Nobel gases, ironically. Newer areas in condensed matter physics have been able to pop up and occur, which again goes back to me saying that more scientists are able to come into the field. And another effect is that there's a possibility of a new topological insulator, which is a material known as stannine. And it is a 1-atom thick layer of tin which conducts electricity at very high temperatures and is theorized to replace copper pieces in computers. And since it is a 1-atom thick layer of tin, it is so small it could be considered two-dimensional. And this further revolutionizes electronics because it lets us make them more and more compact. And the more compact something gets, the more powerful it can get because you could fit more things into it. And since it conducts electricity at very high temperatures, it is much safer for everyday use. Thank you for listening.